Okay, so we're doing a recording of our midterm that we took on Thursday, July 7th. And I'm just going to go through the questions. So this question here, you're asked to find ln. I think it's pretty obvious. It's 37. It's not that hard. Actually, take a peek at some of your questions here. And yeah, pretty easy, right? Not that hard. So that was very, very straightforward. Give me one sec here, and I just did a big mess here in my office. That's 37. Very easy, right? Okay, again, every question is worth 2 points. And if you have questions, just stop me and let me know, or type in the chat, or speak in the microphone. Next is asking to find the length of that segment round to the nearest tenth. So you can just plot the points really quickly. 1, 2 is right here. 3, -8 is right here. And then you just got to draw a right triangle around it. Length of 2 and 10. So it should be root 104, which I believe is 10.2. So hopefully that went fine. Okay. Let's keep moving. Remember, it's 30 questions. Here we have to find the midpoint. So it's got to average the x's and the y's. Not that hard. Maybe 2, 3. So very easy, right? So that's that one. Next up, you're asked to find angle Npq. Well, NPN, this whole thing here, is 85. So 9x minus 6 plus 5x plus 7 must equal 85. So 14x minus 1 equals 85. 14x equals plus 1, oops. So 14x will equal 84. X is 6. If x is 6, then you got to plug 6 into that, which would be 54 minus 6, or 48. So NPQ is 48 degrees. So that's that one. And by the way, for having me going over this will kind of motivate me to grade you guys' stuff pretty quickly. So here you have to find the area. Area is just 1/2 times base times height. That's all. That's your base. That's your height. So 1/2 of 22 times 6, 11 times 6, you get 66. Next up, it looks like I gotta find a pattern. I think we're multiplying by 2. So 48, 96, 192. So again, that should be pretty straightforward. Okay, so we're 1/5 of the way going over this midterm. Next up. Fireworks make noise. So you could say, if there's a firework, then it makes noise. That's going to be the original statement. So I'd say this is D. And then the converse is just you switch. So if it makes noise, it is a firework. Obviously, a lot of things make noise, right? If it is not a firework, then it does not make noise. Again, there are a lot of other things that make noise. So that's your inverse. And then you got to switch and negate to be a contrapositive. If it does not make noise, then it's not a firework. And obviously, if this one's true, then the contrapositive would be logically true, but we just had to identify which was which. So that's that one. Very straightforward, just make sure you can do algebra. X is 7, not that hard, right? Okay, so that's number 8. Number 9, that's just 130, not that hard. Vertical angles, right? That's just 130. Here, since these are parallel, these are going to be the same because they're all to interior angles. So 2x equals 136. X should be 68, I think. Yeah, 68. Okay, so that's number 10. So now we're 1/3 of the way through the midterm. Number 11, you're asked to tell whether these two lines have the same, whether they're parallel, perpendicular, or new. So you got to find the slopes of each. So slope of line 1 will be -2 minus -4 over 6 minus -1, which would be 2/7. Slope of line 2 will be 10 minus 8 or 5 minus -2, which would be 2/7 also. So that's the same slope going to be parallel. So again, pretty easy. The next right equation line that is that passes that point and is parallel to -2x minus 5. So you have to have the same slope, so you can eliminate those two choices. And if you can plug in 2 in each choice, and 2 for x and 3 for y to each choice, and see which one is satisfied. Or you can do this, do point slope form, up to, you know, yeah, so you should get that choice. That should just be 31 degrees because everything adds up to 90. That's very straightforward. Y equals mx plus b. You already know m and b, so y equals 4x plus 3. Again, these are kind of just really just pretty straightforward questions. Okay, we shall keep moving. If that's 52, and that's going to be 38, it'll be 26. Since these are the same, that's 79, that's 26. So you have 105. So that's going to be 75 degrees. So that's all 75 degrees right there. So again, very straightforward. Okay. We're halfway through here. 17. Those are corresponding angles, obviously. So, I mean, obviously, if you said B and K or B and X, it would be neither, but those are corresponding angles, so that's pretty easy. Okay, how are these triangles congruent? Remember, WY is shared between both triangles, and the other sides are the same, so that's a side situation. Okay. Let's keep it moving here. Number 19. All 3 sides are the same, so it's just equilateral, which is also equiangular. So 3x equals 60, x is 20. Again, very straightforward. This one here, we have to solve for x. Well, these are going to be congruent triangles because that's right angle. DV is shared between both triangles, and they have the hypotenuse the same, so they're congruent by hypotenuse-Lake theorem. So you just solve for x. X should be 9. So that's going to be, but you got to be really, really careful with your algebra here. So yeah, that's all that's going with that one. 21. Let's know the angles work from smallest to greatest. We talked about this right before the midterm. Angle T is the smallest. Then angle R is second because opposite the second biggest side. And then finally, angle S. So we should go TRS. Is it possible to construct a triangle with given sides here? Yeah, 13 is definitely less than 5 plus 12. So yes, you can. Just got 8 more problems to go over. For 23, these are going to be congruent triangles because they share the side. The legs are the same. So right triangles, so by HL, they're the same. So yeah, recognize that first. 11x plus 7 equals 3x plus 23. 8x equals 16. X is 2. So again, pretty straightforward. Question 24. You can cross multiply. So you have 40 equals 24x minus 8. 48 equals 24x. X is 2. Again, very straightforward. Not that hard. Jam is 24. PS, I do not know. We'll call it X. ML is 28. SR is 21. Divided by 7, that's 4/3. 72 equals 4x. X is 18. So you get that one there. These are by side, side, side. That's all. So again, very easy, very straightforward. What is y of x? These are similar triangles because you have those are the same, those are the same. So you set up a proportion. So you can say 12 over 16 equals 24 over x. 12x should equal 384. But you could also reduce this before you do that. You could say that's 3/4 if you want. So 3x equals 96. So x is 32. Okay, 3 more questions. Oh, Will's just joining us. Okay, great. 28. Scale factor just means you want to find the ratio. So like obviously 6 and 15 correspond to each other. That reduces to 2/5, or you could compare 10 and 25, same thing. Both those divisible by 5, 2/5 again. The answer is B. Yep, that's that one. Number 29. So that's obviously going to be 42, meaning that this is going to be 42 plus 95, which I know is 137. I got to do 180 minus that number, which is 43. Well, 42, 46, 88. That'll be 92. Yeah, clearly these are not similar. Because you need all the angles to be the same. Okay, and then last one. What we got here? 2, 3, 5. So all the angles have to add to 180, as we know that for a triangle. So you can say 2x plus 3x plus 5x equals 180. 10x equals 180. X will be 18. Therefore, then that's going to be 36. 54, and 90. And so the answer to that one is going to be C. Okay, so that covers the midterm. And actually, while I was doing this, I was grading one of the exams, so that way I can make sure everything seemed legitimate. So whatever exams are graded, I've got 18 more to correct. So I should be able to, I think I should be able to knock this out pretty quickly today. So hopefully I'll have the grades up. And then if you can't see the grade in Schoology, because I think you guys can't see, so it should sync to Power School shortly after I put them in. So I'll make sure they get in there. So, but cool, great. And then just remember, we're not going to be in person again until Thursday of next week, because I do have to work from home on Tuesday. So, but yeah, here we are on Zoom. So hopefully that all made sense. Any questions? Nope. And then let's make sure, take a quick look at attendance. So we're still missing one person. I don't know who we are missing. I'll need to figure that out a little later. We'll only pull up attendance really fast. Let me pause the recording. Okay, we're back to recording. So as I said, I haven't made the schedule yet for the second half of this class. But I imagine it's going to look something kind of like what they did last summer. So just going to try to follow the same kind of schedule, where we're going to have to cover, let me share my screen, 7.1 to 7.3. Actually, I'm going to see if I can do 7.1 to 7.4 today. Let's see if we can squeeze that in. We don't have a 7.8, so we don't have to worry about that. Then we'll do 8.1 to 8.3 and 8.4 to 8.6 on Tuesday, Wednesday next week. And then we'll have our next test on Thursday. And Friday, we'll do, of next week, we'll do 10.1 to 10.3, looks like. Probably 10.4 to 10.7. And then we have 11.1, so probably 11.4, 11.5, 11.7. Then another test after that. We'll just wrap up with one more unit, and then we have our final exam. Okay. So, and it's probably having their downloads. So let me pull up. So, and I handed you guys hard copies of this, and you should be able to find this in Schoology. So, if you go to Schoology, if you don't have the hard, I mean, I gave for 15 of you guys. I did you guys hard copy. 4 of you guys, I know we're on Zoom. I think that was Sadie and Neil, Isaac Jensen, and Dana. So you guys will have to download the documents from here, but it's all right here. And my plan is at least do 7.1 to 7.3 today. We'll see if we can sneak in 7.4. If not, then we'll do it 7.4 to 7.7 on Monday next week. And we'll try to finish by about 12:30ish today is my thinking. And we'll do a break around 10ish. So don't worry, we'll have a break soon. But yeah, so let's get to it. So what I'll do is I'll work out 7.1. You know, I'll do all of it. Then I'll have you guys then do this document, which is a worksheet on 7.1. And then we'll see where we are at timing. Maybe we'll do a break after that. Come back for a break. We'll do 7.2. Kind of, you know, rinse and repeat. I'll talk about it, do some problems. Do 7.3, talk about it, do some problems. Maybe we could get to 7.4. I don't know what's 7.4 about. Maybe we can. Well, let's see. I think we could. And then I'm just going to go easy on you guys. Most likely I won't assign any homework. And then we'll just kind of just do more stuff on Monday. This way you guys can enjoy the weekend. But yeah, I know you guys have worked hard lately, so let's start with 7-1. Okay. Then we close this down, that down, that down. Okay, Pythagorean Theorem. So we have talked about this. It's something you should have seen in middle school. Hopefully saw in Algebra 1 last year. So you have a right triangle. A and B are the legs. C is the hypotenuse. And A squared plus B squared equals C squared. That's it. Don't worry about the word plexor. I have no idea what's going on with that. Now the first question is, do these sides form a triangle? Remember, longest side is less than the sum of the two other sides. Very, very important, okay? So 9, is that less than 2 plus 8? You bet. So yes. Is 15 less than 5 plus 10? No, it equals it. So that's a no. Is 78 less than 58 plus 39? Yeah, because 58 plus 39 is pretty big. That's 97, I think. So that's yes. And again, Pythagorean theorem right there. I wrote it right above. It's a very, very simple concept. So some Pythagorean triples, meaning all these satisfy Pythagorean theorem. So if you did 3 squared plus 4 squared, does it equal 5 squared? You bet, right? 9 plus 16 is totally equal to 25. Likewise with 5, 12, 13, 8, 15, 17, 7, 24, 25. All the other ones you see below. Even some that have like X next to them, big deal. The X just goes away. But those are common ones. Usually I'd say 3, 4, 5, 6, 8, 10 are ones you see most often, maybe 5, 12, 13, 8, 15, 17 sometimes. Maybe 7, 24, 25. But these other ones are kind of rare, but it works. So here, you're just asked to apply Pythagorean theorem to find X. It's not that hard. And round to the nearest 10. So I'll call this side C. I'll call this B. I'll call this C. And I'll call this B. If you want to call that A instead of B, it doesn't matter. They're interchangeable. So all you're doing for this one is you're doing 4 squared plus 9 squared equals C squared. 16 plus 81 equals C squared. C is root 97. Now, if you wanted to give us a decimal, you use a calculator. So root 97. This is going to be very boring, very not mind-numbing work to reduce this. That's 9.8, right? Not that hard. Next up, you have 9 squared plus B squared equals 28 squared. Okay. 81 plus B squared. What's 28 squared? 784. So 703. So B is root 703. Or B could be approximately 26.5. And obviously this has to be less than 28 because 20 is the biggest side, it's the opposite 90 degrees. So I want you guys to try these two really quick. We'll just spend a couple minutes. I'll pause the video. Okay, so we're recording again. So here are the answers for the other two. You get root 109 when the legs are 10 and 3, or 10.4 for the hypotenuse. One leg is 7 to hypotenuse 16. You wind up getting a root 207 or 14.4 as the other leg for that one. And another thing that just came to me is that you know, if you do have test corrections for test number 2, please get them in today if you can, so I can help you out if you if you need for test number 2. So because I'm going to be updating grades over the weekend. Okay, let's keep moving. And if you feel like you want to do a test question for the midterm, only problem is that I won't be able to get that back to you until Thursday. So I might make those due until like the week after, but there'll be an opportunity for that, don't worry. All right, let's do some stuff on area of triangles. And then some word problems, and then we'll do a worksheet, and we'll do it in a breakout sessions for worksheets. All right, so let's see here. Find the area of the shaded region. Well, you're going to have to do Pythagorean theorem to get this side. So 4 squared plus 6 squared equals c squared. That'll be 16 plus 36. 52 is c squared. C is root 52. Now, this shaded region is going to be the area of the big square minus the area of the small square. For the big square, you got 10 times 10. That's easy. For the small square, because that's root 52, and root 52, you're doing root 52 times root 52. So it's 100 minus 52, and you get 48. So you could approach it that way, where you take the area of the big object minus the area of the little object. So the little object obviously is the middle, which is not shaded. Subtract from the area of the big, you get that. Or you could have done this, completely blow this up. You could just do 1/2 times 4 times 6, 1/2 times 12, sorry, 1/2 times 24, which is 12, but then you got to multiply that by 4. You get 48. So that works also, because you have 4 triangles. So it's up to you, whatever you prefer. Obviously, the way I just did, I didn't have to use Pythagorean theorem. And I just found the area of each triangle. So it's your call. For 7.1.3, because it's an isosceles triangle, this gets cut in half. So that's 15. And I'll call this A here. So a squared plus 15 squared equals 18 squared. Why do I need to find the, that segment that I label as A? So that's going to be the height of the triangle. Actually, let's call it H, because it is a height. So H squared plus 15 squared equals 18 squared. And remember, area of a triangle is 1/2 base times height. So if you solve it, you should get 225. And I think that's 324, but I'll use a calculator. Yeah, 324. That gets us 99. So H is root 99. Which is approximately 9.9. Sometimes it might be good to round a little bit more when you have to use it into another calculation, just so your answer is a little more accurate. So 1/2 times 30, that's my base. My height's 9.95. So that's gonna be your base, right? Because the height's always perpendicular to the base. And if you multiply that out, you should get 149.2. So that's all for that one. You do the same thing here. That'll be 10. And you have to do Pythagorean theorem again. 10 squared plus 8 squared equals 26 squared. This actually is going to be one of our Pythagorean triples. So it's 24. I mean, you should work it out just to be sure. That's 100. 625, I think 676. 8 squared is 576. H is 24. Then find the area. 1/2 your base, you're going to say your base is 20 times your height. You get 240. 240 for that one. And by the way, I forgot to state the units as well. That's meters squared. The other one was feet squared, 149.2 feet squared. So hopefully we're okay with that. Okay, then we got 2 more problems here. I'll try this one, have you guys try the word problem. She has to solve for x. I mean, I gather that this is 47.57, that's 22.26 twice. So not that hard. 47.57, 23.26, I'll call this x. So x squared will be 47.57 squared plus 23.26 squared. You just work it out. 7.57 squared plus 23.26 squared. Root it. Yeah, you get a really big number here. It's 2803.93. We square roots. Should get 52.95, or we could say 53, because you round up, so 53 meters. Again, not the most exciting problems, they're pretty straightforward. Now here you have to solve for D. So it looks a little confusing, but that's 5 right here. So you got a right triangle like this. And D represents how far the base of the pole is, wire. The pole is each wire attached to the ground. Okay. So just solve for D really quickly. Just take about 30 seconds, shouldn't take too long. Okay, so it should be 6 squared equals 5 squared plus D squared. 36 equals 25 plus D squared. D squared will be 11. D is root 11. And if you were to punch in the calculator, you get 3.3. So it'd be 3.3 feet. That's all. I noticed I didn't even really read the other stuff, just look at the diagram. The diagram is sufficient for doing the question. So yeah, it's not a hard concept. It's not terribly stimulating, but something we gotta do and just make sure you guys got it. I've kind of assumed that you guys knew this anyway. Hopefully you guys have been fine with some of the right triangle stuff we've done lately. So now what I have you guys do is work on the next one. So if you have the hard copy of the packet, that should be the next page that shows up. We'll say 7.1 worksheet. The odds are included, so you can see if you're doing this right. Obviously the evens are not. So we'll go over the even answers when we come back from the breakout session. But you can see like 1, 2, 3, just solve for x using Pythagorean Theorem. It seems like x is the hypotenuse every time. 4 and 5 describe the error that was made, so you gotta explain that. 6, 7, 8 are just diagrams, and you have to solve for x. Looks like x is the legs in each case. 9, 10, 11, you have to find the area, but you have to solve for the height by using Pythagorean Theorem, meaning that these bases get chopped in half. And remember, area is 1/2 times base times height. Not that hard. We know this. And then you have a word problem here, which actually is a good problem. I know there's some of you guys played baseball. Told you guys Giants going to lose last night. I mean, we didn't get smoked, but Musgrove dominated. I think we're going to lose again today too. I think Blake Snell is going to have a strong game today. Not a Padres fan, I'm a Giants fan, but I'm a realist too. And when the top of the lineup is going to be Austin Slater and Wilmer Flores and Darren Roof. It's not looking too good. So anyway, and I guess some of the no-name guys on the team as well. I think one guy, the cleanup guy's last name is Mercedes. But yeah, anyway, I digress. So you guys are going to work on this. It's 9:46. We'll set the breakout session for about 15 minutes. I think that's more than enough time. We'll talk about it, and then we'll do a break after that. So let me stop sharing my screen. Put you and stop, pause. So hopefully the odds made sense when you saw the answers, like 1 and 3 were 130 and 58. If you were to work those out. If you do number 2, you should have 33 squared plus 56 squared equals x squared. So let's see here, 33 squared, square root it. Yeah, you should get 4225, so x is 65. So yeah, that's all. Pretty easy, right? What's the problem here? These are switched. So you gotta swap those two. That was the problem. So this should be 10 squared plus 24 squared equals 26 squared. And if you were to work that out, you get not 576, 676 on each side, I believe. Yeah. For this one here, you don't put those in parentheses. That's not a thing. That's actually really bad form. You just gotta just say it's 49 plus 576, which will be I think 625. Now I guess 25 is an answer, just so you know. So that was a mistake for that one. And I think they explained it, yeah, right there. 7 obviously is just using Pythagorean Theorem. Do the same for 6 and 8. X squared plus 8.9 squared equals 16.7 squared. And likewise over here, x squared plus 4.9 squared equals 5.7 squared. Solve for x, and we'll just work that really fast for you guys. 16.7 squared minus 8.9 squared. Root it. You get 14.1. 5.7 squared minus 4.9 squared. Root it. You get 2.9. So again, pretty easy stuff. Those are each in feet. Not that hard. 9 and 11 will work out for you. They give you the areas right there. I believe if this was 8, that was 15. So that's why I have half of 16 times 15. That explains why you get 120 as your answer for that one. Square meters. This one here, that's 6, that's 8. So you have half of 12 times 8. That will explain why you get 48 centimeters squared. This one, that's 16. I think that's going to be 12, if you did Pythagorean Theorem correctly. So you have half of 32 times 12. 16 times 12, that should be 192 feet squared. So I believe that is all correct. Okay. Questions on 9, 10, 11 before I talk about 12? Okay, let's talk about 12. Yeah, so this is actually a little more interesting because I know some of you guys play baseball. So 90 feet from home to first base, right? So here's home, here's first base, here's second base, here, of course, here's third base, right? And the pitcher's mound's over here, right? So there's your baseball diamond. So how far does the ball need to travel if it's from home plate to second base? And a lot of times that's important because you can have someone at first base who wants to steal, right? And so, you know, you want to make sure that the catcher can throw it fast enough to get, you know, the runner out at second base. So you want to find that distance. So if that's 90 and 90, and obviously we don't care about the pitcher's mound right now, But yeah, you just got to do Pythagorean theorem. I'll call that x. So 90 squared plus 90 squared equals x squared. That's 8100 plus 8100 equals x squared. That's 16,200. Square root it. Oh, goodness. $127.3. And that's feet. Okay. That's it. That's what you do. Any questions? Nope. Okay. So it's about 10:09. Oh, Nina, go ahead. Let me undo it. You need to still copy.
Can you go over 5? Or
sure. Yeah. Let's talk about 5. The mistake there is that you can't just put parentheses around 7 and 24. Like, for example, like if you have 3 squared plus 4 squared, right? I know it's 9 plus 16, and that's 25. If I do this, I get a different answer. It's because of the order of operations, right? PEMDAS, please excuse my dear Aunt Sally. You get a different result. So you can't do the parentheses around it. So that is a bad step. Instead, we have to say x squared just equals 49 plus 576. And then x squared equals 625. And then x is 25. That's how you correct it. So that's number 5. But you can't just be liberal with the parentheses like that, because then it would disobey the order of operations. That's a really bad thing, that second step.
Thank you.
You're welcome. Okay, so it's 10:10. Let's do a 15-minute break. So let's come back at 10:25. At 10:25, we'll do 7.2, and we'll do a worksheet there. And maybe we could probably even sneak in 7.3 as well. And then we'll do a lunch break around 11:35, 11:40. Come back. Maybe I could sneak in one more topic. Maybe I could sneak in 7.4 with you guys. So that way we don't have as much to do on Monday. But anyway, and I'm not going to assign any homework because I think this is pretty straightforward stuff. But we will review everything on Monday. So, I'll definitely make sure you guys are on it. But yeah, I think that's that. And we'll do a break and we'll come back at 10:25. All right, sorry about that for the little delay there. I'm back. Okay, so let's get back to doing some more work. We'll still do a lunch break around 11:30. I think we should be able to knock out the next 2 sections before lunch. Then we'll come back around 12 or so, and then we'll do one more section, so that way we don't have all that much to do on Monday. Okay, so I share my screen. And let's start recording. Okay, here we go. So let me open up 7.2. Okay, this is going to be about simplifying radicals. And it looks like kind of going backwards a little bit. Okay, not sure if you guys have done simplifying radicals in the past. Hopefully have in Algebra 1. But if you're to simplify this, you want to do something called a prime factor tree. So you want to break down 12 into its prime factors. Remember, a prime number is a number that has exactly 2 factors, just one itself. So 12 obviously has a bunch of factors, right? 12 has 1, 2, 3, 4, 6, 12. Those are all factors of 12. But if you break it down to its prime factors, you can do 2 and 6, and then break the 6 down to 2 and 3. So this means that 12 is 2 times 2 times 3, or 2 squared times 3. So if I were to square root, then I could say it's a square root of 2 squared times square root of 3, or 2 root 3. That's all. So 12 is 2 root 3. That's how you can simplify it. You do the same thing for 50. Break it down to, like, say, 2 and 25. Break it down to 5 and 5. So then you got 50 is 2 times 5 squared. If I were to square root, obviously squaring both sides, then you got yourself root 2 times root 5 squared, or root 2 times 5, so it's 5 root 2. So that's how you can simplify that one. And if you were to put the 5 back in, then it becomes 5 squared, and then you get back to root 50. Or if I were to put the 2 back into here, that 3 times 2 squared, and get back to root 12. So that's how we simplify radicals. And then we don't care about the word flexor. I don't really understand that. Let me undo my work. Nina, you have a question?
I was just gonna ask if you could go back.
Okay, so yeah, here we go.
Oh, you did go back.
Yeah, no problem.
Thank you.
Yeah, so again, 12 is 2 times 6. 6 can be broken as 2 and 3. So you have 2 squared times 3, that's 12. And when you square root, you have square root of 2 squared times 3, or square root of 2 squared, which I know is 2. So that's how you can get 2 root 3. Or 50 can be broken down as 2 times 5 squared. Root 5 squared, that's root 25, that's 5 root 2. There we go. So any questions? All right, let's keep moving. Again, we know about Pythagorean theorem. She has to solve for x. X is right here and x is right here. She has to solve from this side actually. And you want an exact answer, so no decimals. So in this case, I do 4 squared plus 10 squared, which is x squared. 16 plus 100, which is x squared. X squared is 116. Or x is root 116. Now, you could break this down into its prime factors. Let me see here. 4 and 29. And then 2 and 2. So 116 becomes this. 2 squared times 29, or 2 root 29. Another way you can think of this too is that whenever numbers occur in pairs or factors occur in pairs, you just pull them out of the radical. So that's how you would express that as a more exact answer, 2 root 29. Root 116 is also exact, but we can simplify it like that, 2 root 29. And you want to get in a habit of doing that because we're going to see that often when we start doing trigonometry. And just in general, when you move on to more advanced math classes like in Algebra 2 and pre-calculus, that is kind of the expectation, is to simplify radicals. So you want to get in a habit of doing that. So that's the first one. Any question about the first one? Okay, let me clear. Let's do the next one here. 6 squared plus x squared. Yeah, Neil, go ahead.
From the one you just did, what would you circle as your final answer?
2 root 29. Yeah, I definitely did 2 root 29. All right, so now let's keep moving. X squared plus 6 squared equals 8 root 3 squared. So you have x squared plus 36 equals 64 times 3. And what I'm doing is I'm squaring the 8, which I know is 64, and squaring the root 3, which I know is 3. Because you're doing 8 root 3 times 8 root 3, which comes 64 times root 9, which is how you get 64 times 3. So when you multiply radical by itself, the radical goes away, right? And of course, 8 times 8 is 64. So x squared is going to equal 156, or x is root 156. Now, I'm going to break that down into its prime factors. You can use a calculator to help you. 4 and 39, and then 3 and 13. But 3 and 13 are already prime. So I could think of this as, and 4 I know is 2 and 2, obviously. So you have this. So you have 2 root 39. And that would be my answer for that leg. Yeah, it's interesting. I think the other one we had, 2 root 29. So anyway, it's kind of interesting. So yeah, instead of giving a decimal or a radical of the big number, we want to pull out perfect square factors, put it that way. We're pulling out factors of these large numbers that are perfect squares. 4 is a perfect square because 4 is 2 and 2. So you're pulling it out of the radical. And when you pull it out, you take the square root of 4, it's 2, and put it outside the radical. That's exactly what we're doing here. So I'm gonna have you guys try. So this will be 7 squared plus 7 squared equals x squared. This will be 3 squared plus x squared equals 4 root 6 squared. And then you're going to solve for x, and then, of course, give a simplified radical. Okay, so you should have 49 plus 49 equals x squared, 98 equals x squared. So x is root 98. Over here, you should have 9 plus x squared equals 16 times 6. 9 plus x squared equals 96. X squared will equal 87, if I'm not mistaken. So x is root 87. However, we want to simplify each of these if we can. Let me try to do that right. 4 root 6. Yeah. Minus 9. Yep. Now, 98 can be broken down as 49 times 2. And 49 can be broken down as 7 and 7. So you can write this as 7 root 2. However, root 87 gets broken down like this, 3 and 29, which are both prime and are not repetitive. So you just say root 87 for that one. So again, those are exact answers. Those are the answers for those two. I'll give you guys a moment to copy it down. Okay, so let's keep moving. So here, obviously when this happens, when two of the sides squared and added up equals the longest side squared, the longest side we call the hypotenuse, that is going to be a right triangle. But what if c squared was less than a squared plus b squared? So it means that this angle bends in a little bit. So for example, like what if I had like 4, 5, 6. So it'd be 36, and it'd be 16 plus 25. Obviously 36 is less than 41. Because in order for this to be a right triangle, you would need this side to be bigger. You would need that to be root 41. Whereas if c squared is bigger than a squared plus b squared, then the angle c is going to be greater than 90 degrees and it'll be obtuse. And remember, we're squaring, so it's not the triangle inequality theorem where you just do a plus b and compare it to the biggest side. It's the square of a and b, or a and b squared separately and then added up, and you compare that to c squared. So that's how you can classify a triangle by using its side lengths. So here, what type of triangles do we got? Well, let's do 65 squared. Let's do 72 squared. Let's do 97 squared. Let's just do those all individually to see what happens. And then we'll do likewise 11.4 squared, 21.2 squared, 23 squared, 2 squared, 6 squared. Oop. Okay, so 65 squared, what do we got there? 42.25. 72 squared, what do we got? 51.84. 97 squared, what do we got? 94.09. Do those add up? And you know what? I think they do. So that's a right triangle. Now here, 11.4 squared. .2 squared. And 23 squared. And I don't think those add up. In fact, actually, all this as of the 579.4. So it's pretty clear that 529 is less than the sum of the squares. So this is going to be an acute triangle. Because 529 is less than 579.4. Lastly, you're going to have 4, 36, and 9 times 5, which is 45. Let me make that a little neater. That's hard to read. Four plus 36 is clearly less than 45. So that's going to be like this one here. That's going to be obtuse. So that's how you can classify triangles by their angles, whether it's acute, obtuse, or right, based upon, we call it the Pythagorean Inequality Theorem, if you want to call it that, where you do Pythagorean Theorem, but what you're really doing is you're comparing a squared plus b squared to c squared. If a squared plus b squared equals c squared, it's right. If a squared plus b squared is greater than c squared, it's acute. If a squared plus b squared is less than c squared, then it's going to be obtuse. And we saw all three cases there for A, B, C. Any questions? Okay, so now we scroll down. You guys try that. And then you guys tell me whether they're acute, right, or obtuse. I'll tell you now, we are going to have one of each situation. And I want you to put in the chat, just do like this, D, E, F, and tell me what it is. So I'll give you guys a few minutes to do that, and then we'll move on to the next part, 7.2. And I'll pause recording. Okay, I'm recording because I want to make sure you guys got this. So again, all you do is you just square each of the numbers and compare them. Obviously, you're comparing the two smaller sides to the bigger side. 10 squared plus 14 squared, that comes out to 296. That is bigger than 17 squared, which is 289. That makes D acute. For E, that's going to be obtuse because you have 8 squared plus 13 squared, which I believe is going to be less than 16 squared. And then you have 1 squared plus 5 squared, which adds up to 26. Root 26 squared is 26. So that's the right triangle. For the one word problem down here, if you say you have a painting that's 10 by 18, and if you want to guarantee the corners are at 90 degrees, so if that's 10 and 8, then I would expect this, and assuming that's the right angle, I would expect this to be the square root of 10 squared plus 8 squared, or root 164, which is approximately 12.8. So then if I were to get a ruler, I'd want to make sure that the diagonal measure is 12.8 inches. If it doesn't, then I know that something's up here. That is not a right angle. But I would expect this to be 12.8. Or you can take a piece of string and then measure it, and it should measure 12.8. That would guarantee. If we're more than 12.8, then you know this is greater than 90 degrees. If it's less than 12.8, then you know it's less than 90 degrees, and therefore it's acute. So if that makes sense for that one. All right, so now I'm going to have you guys do is this worksheet here. Again, we'll spend about maybe 12 minutes on it. And you're asked to decide if the lengths form a triangle. If so, would it be acute, right, or obtuse? So first you have to compare the longest side to the sum of the other two. Like for example, I'll tell you right now, number 5 is not a triangle. Because 36 is more than 15 plus 20. So you don't have to waste your time with that one. Whereas number 1, that would be a triangle. 10 plus 11 is greater than 14. But then what you have to do is you have to compare 10 squared plus 11 squared, and I'll put a box here. 14 squared, you get 196, 100, and 121. Well, 221 is definitely bigger than 196, right? 221 is definitely bigger than 196. So in that case, that's going to be acute. So you can do something similar for 2, 3, 4, 6, and 7, 8, 9. And then you're asked to solve for x, for 10, 11, and then 12, you have a word problem. So I'll have you guys do this. We'll go and copy it down first. I'll give you a chance to copy it down, and then I'll put you guys in breakout rooms. Yep. Any questions on 1 and 5? And remember, when you're asked to determine if the lengths will form a triangle, you want to compare the biggest side to the sum of the other two. Now, for 2 and 3, those are going to be a little complicated because you have radicals. So you can use your calculator 5 root 13 is roughly 18.03. 6 root 43 is roughly 39.3. So I'm pretty sure both of those are going to be triangles because 39.3 is not greater than 24 plus 30. 18.3 is not greater than 10 plus 15. So I think you're going to be okay. And in fact, actually, there's only one other scenario that's not a triangle. I'll let you guys figure that out. But 2 and 3 will be okay. If those are triangles, then you got to do the a squared plus b squared compared to c squared and see what happens. So anyway, let me put you guys in breakout rooms again. We'll do this for 15 minutes. Pause record. Okay, so the odd answers are provided. 1 was a cube, 5 was not a triangle. I think I did this for you guys, right? 9 is not a triangle, just so you know, because 65 is more than 23 plus 40, so 9 is not a triangle. I think they have that as well. To work these others out, that's going to be 100, 225, and I think that's 25 times 13. 325, so that's a right triangle. Here you have 24 squared, 30 squared, and 6 root 43. So you have 576 plus 900 and 1548. So clearly that's 1476. That's less than 1548. So that's going to be obtuse. I think the answer even says obtuse for that one. Yep. Let me just do the rest of these because it's just interest of time. 4, I believe, is going to be acute because you have 25 plus 36. That's less. That's greater than 49. 6, you have 64 plus 100. That's greater than 144. Acute again. Here you can have 25 plus 64. That's less than 144. That's obtuse. I believe 7 is a right triangle. Just to work that one out. For 10, if you do Pythagorean theorem, that's 4. Then you have 4 squared plus 7 squared equals x squared. 16 plus 49 is 65. X is root 65. There you go. And you can't simplify that. That's going to be 11 because you have the markings. That's 11. 11 squared plus 11 squared. That's 121 plus 121 is x squared. So you have 242 is x squared. X is root 242. X is 11 root 2. So that's all. And I shouldn't say that's all. I mean, obviously you got to break it down. It's 121 and 2. And then that becomes 11 root 2. And that's one thing you should notice with right triangles, that when you have, and we'll probably, if we do get the 7-4, we'll talk about it. But if you do have two sides of the same, 2 legs the same, then the hypotenuse is 11 root 2. Nina, go ahead.
For number 10, how did you get 4?
Pythagorean theorem. It's one of the Pythagorean triples. I mean, you could do this if you want. Oh, hold on a second. Okay. Yeah, so if you call this like side A, for example, 3 squared plus a squared equals 5 squared, 9 plus a squared equals 25. A squared is 16, A is 4. And that's that. And then, of course, you get, we solve for x afterwards. And then the word problem down here, do directly north. Well, hold on. You walk 749 feet due east to the gym from your home. From there, you walk 800 feet southwest. Finally, you walk 395 feet from the library back home. So the library is right here. So you're curious to know if this is a right angle. So you have to do Pythagorean Theorem. 305 squared plus 749 squared and compare it to 800 squared, right? 305 squared, that's going to be 93,025. 749 squared, that's going to be 561,001. 800 squared is 640 thousandths. So if you do 561,001 plus 93025, that becomes 654,026. Obviously, that's bigger, so this is going to make this actually an acute triangle. So the answer is no. You don't have to look direct north because it's not a right angle. So that's number 12. Okay, so it's 11:35. We still have to cover 7.3. So let's come back in 30 minutes at 12:05. So 12:05 we'll come back and we will do 7.3. So we probably won't get to 7.4. Let me clear this right now. Yeah, because 7.3 we have to talk about more about similar triangles, it looks like. Okay, geometric mean. Yeah, so actually it's not that hard. It's a pretty easy topic. And 7.4, yeah, we'll save that for Monday. And then 7.5, 7.6, 7.7. I guess chapter 7 test review, that will be homework then. So that's what we'll do. So anyway, let's do a 30-minute break and I'll see you guys at 12:05. Okay. And here's 7.3. Let me close the other ones down. And let me also look at the other part of 7.3. So our goal is to, let me share my screen. Our goal is to finish both of these worksheets, and then we'll be done for today. So I'm going to talk about similar triangles again, and kind of an interesting way of looking at similar triangles. And then you'll do a worksheet on it, and then we'll be done. And again, we'll do 7.4 through 7.7 on Monday. And most likely, and we're Zoom again Monday, most likely we'll do a test review as homework that day, but no homework over the weekend. So yeah, you guys enjoy the weekend. So just to quickly review, don't worry about the word plexure. So when you have a proportion, you can cross multiply. That should be pretty straightforward, right? So x times x, x squared, 18 times 17, whatever that is. And 18 times 17, let me multiply that out. You get 306. So x is root 306. Which is 17.5 roughly. Okay, so we're going to be working with proportions throughout this section because it's doing similar triangles. So this is the part that's a little tricky. So bear with me here.
So you got ABC, which is all this. You got CBD, which is this. And you got ACD, which is this. Apparently, when you form a right triangle in this manner, so you do a right triangle, ABC, and then you drop the altitude from the right angle to the hypotenuse, as they say here, an altitude is drawn on the hypotenuse of the right triangle. The two small right triangles you get are going to form similar triangles. How do I know that? Let me help you out a little bit to get a better understanding. So let me go to a whiteboard. And let's say this were 90. Okay, let me draw a little better. So you have 30, 60, right? And let me label the corners. Okay. And of course, this would be 30 degrees right here. And of course, that'd be 60 degrees right there. Because ABC is 90, and if angle C is 60 and angle A is 30, then angles CBD and angles ABD have to be 30 and 60 respectively. And of course, you have right angles here and here. So if I were to redraw these three triangles, here's the whole triangle again, and I reoriented it. So that's B, ABC. Remember, that's 30 degrees. Angle C is 60 degrees. And then if I look at one of the smaller right triangles, let's say ADB, that's 30 degrees, that's 60 degrees. And then I look at BDC, that's 30 degrees. And that's 60 degrees. You're going to see all corresponding angles all equal each other. Angle A, and then this angle B here. Angle C, angle B, angle C, and then these right angles here. So you wind up forming three similar triangles are all right triangles as a result. So that's why when you drop the altitude, you wind up generating those similar triangles. When you drop the altitude from the right angle to the hypotenuse. I mean, if I were to use some different angles here, like say that's 20 degrees and that's 70 degrees, then this would be 20 degrees and that would be 70 degrees. Right? Still works. So it's still all good. You're still gonna have the same situation. So now let's go back to the worksheet. So identify the sum of triangles in this diagram. So triangle RTS, that's a big one, is gonna be similar. And I remember I'm going small angle, right angle, and then the medium angle, which is angle S, is gonna be similar to triangle TUS. And that's gonna be similar to triangle RUT. And if you want, you can make up angles here. You can say maybe that's like 60 and that's like 30. And then that would be 30 and that'd be 60. And you can see that it would all just make sense. So now you want to try doing the same on the triangle to the right. So your goal is to identify the sum of triangles, putting in the right order. So you could say LMK. I'll get you guys started. Is similar to triangle. Now, you guys try to figure out how to order. So obviously you're gonna have this. And we get different colors. And then you have this. But you guys say in the right order. So if I did LMK, I did small angle, right angle, medium angle. So the pink would have to be L and M. And the green would have to be M and K. There you go. So if you need a chance to copy that still. And Neil, do you have a question?
So LMK was just like the whole thing, right?
Yes, exactly. And I had total freedom how I want to order that. But you just have to make sure that the way you order the other triangle, like the way you put the ordering of the letters for the other triangles, that the corresponding angles match up. And again, it's just this kind of interesting phenomena that happens when we have a right triangle. And whenever you draw an altitude, a perpendicular segment from the right angle to the hypotenuse, the other two triangles you form will be similar triangles to the big triangle. Now we're going to start trying to figure out how to find some of the missing sides. This is the part that can get a little tricky. So what I'm going to do is I'm going to redraw each of these. So here's my big triangle. That's 15, 8, and 17. That's R, T, S. Then I got my medium triangle. This is going to be R, U, T. So R, okay, that's a crappy looking triangle, just go with it. R, U, T. And that's R, U, we don't know. U, T, we know is H. R, T, I know is 15. And then finally, we have T, US. T is H, US I don't know, ST I know is 8. Okay, so you're asked to find what H is. So you could just do this. You could just say H over 8 equals 15 over 17. That could work. So 17H equals 8 times 15. You get 120. H is 120 over 17. That's not reduced. That's not, we can't simplify that. So that's your height, 120 over 17. Now there is a quick and easy way, but I don't want to show you the quick and easy way because I want you to break down the triangles and just use proportional reasoning to get the answer. And also see that these are similar triangles, right? By just hypothetically coming with values for the angles and seeing, oh yeah, of course they're similar. All these corresponding angles equal each other, right? Well, there is a quick and easy way. The quick and easy way is that if you call this say you call this C, and say I call this H, and say I call this A and I call this B, the quick and easy way is that H times C equals A times B. That's kind of the quick and easy way. And we could have done that over here. You could have just said H times 17 equals 8 times 15. And that would have worked for us. And it lends itself to something called the geometric mean, which I'll go over in just a little bit. But you can see how CD acts as a small leg for this triangle, but a big leg for that triangle. So that's one way of kind of like looking at it. So you can see how they do BD to CD, so do small leg to big leg, and then we do CD to AD, small leg to big leg. If you cross multiply, you wind up getting BD times AD equals CD squared. Or what you could do, if you call this like this right here X, this right here Y, and that here H squared equals X times Y, where H is square root of X times Y. And that is called the geometric mean. When you multiply two numbers and take the square root. So those are the ways of looking at it. So in this case here, because you have this kind of scenario where you're drawing altitude to the hypotenuse, and you want to solve for y. So you could think this is like leg to hypotenuse, so 3 over y. And then leg, now y is a leg, to that hypotenuse. Y squared is 27, y is root 27, or 3 root 3. So let's look at this word problem here. So some guys in a basketball gym, it looks like Golden State Warriors colors. And he's saying 8.5 feet away from the wall, and the person's eyes is 5 feet off the ground. And you want to know the height of the gym wall, which obviously is going to be 5 plus W. So we got to figure out W, right? So in this case, you could just say 8.5 squared equals 5 times W. The reason why you could do that is that what if I compare 5 to 8.5? And that's going to be 8.5 over W. Because I compare 8.5 to W. So small leg to big leg, small leg to big leg from the two similar right triangles. Or 8.5 squared equals 5W. And then you can solve for W. So it'll be 72.25 divided by 5, you should get 14.45. So the gym wall, the height of the gym wall is going to be 19.45 feet. which kind of seems realistic. I don't know. I mean, it's kind of a small gem, to be honest with you, but yeah. So that's what you got there. So yeah, you could use some math if you wanted to estimate the height of a wall, and maybe if you're doing some sort of construction, or you want to put some sort of a obstacle course in the gym, or do something, I don't know, but that's kind of interesting. That's kind of a cool problem. So that's 19.45 feet for the height of the gym wall. Any questions before we do some practice? Okay. So I'll have you guys try some problems. Let me zoom out just a tad. So your goal is to solve for x. Remember, you could say, if you compare a leg, there's a few ways you could look at it. Like here, you could say for number 3, for this one here, you could say, well, let's look at number 1. X over 3. So that, this leg to this hypotenuse, you can say equals 4 over 5. This leg to that hypotenuse. Or here, you could say this big leg to that hypotenuse, x over 5, equals this big leg to that hypotenuse, 12 over 13. The reason why I was able to do that for number 3 so easily is that really you're saying small leg to big leg, 10 over x, equals x over 18. And that's why you get x squared equals 10 times 18. And lastly, you could say like 5 over x, that leg to hypotenuse, equals x over 9. Actually, does that make sense? Hold on. Yeah, 5 over x. Yeah, I believe that's right. So you see x is root 20 here. X is root 180 here. 5x equals 12x is 12/5. And 13x equals 60. X is 60 over 13. Okay. Questions before we do some practice problems? Okay, so let's do some practice problems. We'll go back to another breakout session. So you guys have been working on this one, more of the same stuff. You do have the odd answers. It's actually pretty short. It's only 6 problems, so it should go by pretty fast. We'll actually do this for 10 minutes. Shouldn't take that long. And then we'll talk about what we've done by 12:45. So I know we're going a little longer than usual. Let me stop sharing. Let me pause. Share screen. Okay. So in this case here, you're going to just say 18 squared equals 12 times y. Where here, you could say 16 over 27 equals 27 over z. And if you were to work those out, what's 18 squared divided by 12? So you have root 27, which is 3 root 3, by the way. Over here, you have 27 squared divided by 16. So z is going to be 729 over 16, which is 45.56. Okay. For 3 and 4, you're going to have x squared equals 4 times 9, which would be 36, which would be 6. Here, you're going to compare x, excuse me, x to 10, no, x to 8. So this leg to this hypotenuse. Hold on, why am I drawing a blank here? Well, this is 6, obviously. Yeah, to 6 over x. Because you're comparing the big leg to hypotenuse, big leg to hypotenuse. So x squared is 48. X is root 48, which of course is 16 times 3. So you get 4 root 3 for that one. So looking at the answers, yeah, 27, 6. It actually should be root 27 for number 1. That's kind of weird, but anyway. Number 5, y squared equals 5 times 8. You have the luxury of just doing that. But really, it's just like saying 5 over y equals y over 8, just so you know. So y squared is 40, y is root 40, which is 2 root 10. You have like 6 point something. And then lastly, Paul and Mary want to determine the height of the monument at local park. We'll call this x, we'll call this y. So you can say 7.2 squared equals 5.5x. And here you could say oh, that's a little tricky. I would do Pythagorean theorem to get this side first. If I do that, yeah, I think I get 7.365. So then I do 7.365 squared equals 6 times y and solve for y. So if I solve for x, I get 9.43. Solve for y. I get 9.04. So their calculations are a little off. Actually, no, not too far off, because if you add 5.5 to that, you get 14.93. Add 6 to get 15.04. So they're actually pretty close. They're not too far off. But that's a word problem using the stuff we just talked about. Okay. So that covers one other topic on geometric mean. We'll do 7.4, 7.5, 7.6, 7.7, all on Monday. my guess is because we don't have any homework, we could probably hit the ground running by maybe covering 7.4, 7.5 for about an hour and 20 minutes and do a break. Then another hour and 20 minutes doing 7.6, 7.7. And then having a lunch break and then kind of starting the homework. So I think we totally finished chapter 7 by Monday. And then of course we'll do chapter, and then we're on Zoom on Tuesday, just so you know, we're not in person on Tuesday. And it's 9:30, 11:30. So I was gonna make it really kind of action packed. Yeah, and no problem. If you need to stay behind and chat, I will be here. But cool, I think we're all squared away. And I'll stop the recording.